morning, everyone. I hope that you have had a good time at the Cohesion Conference. Thank you so much for being a part of our first virtual conference. I know that there have been some hiccups along the way, but all in all, it's been a great conference. And I want to thank you, the attendees, and I also want to thank our exhibitors for working with us and making this one of the best conferences ever. Today, I'd like to welcome you to Enterprise Integration Architecture, a foundational success factor for digital transformation. Our presenter will be Jason Powell with Hire Digital, and I'm looking forward to this session. So, Jason, I'll turn it over to you.
Okay, thank you, and hello, everybody. Hopefully you're all in the right place for this Enterprise Integration Architecture presentation. Just to kind of get started and give a quick introduction, I feel like most institutions understand that that the student experience has to evolve as students have different expectations nowadays. And what I'm going to talk about is how revamping your integration architecture isn't just a great plan from like an architectural standpoint, but also how it can improve the student experience and why it's important when you're going through your institution's digital transformation. And just as an introduction, I work for a company named Hire Digital. Hire Digital is all about, it's a digital transformation management company, and we're all about more quickly and more affordably helping institutions transform themselves and meet the needs of your current students today and also your future students. And so what we're trying to do is fundamentally improve how institutions plan and manage their digital transformation. So first, we're going to go through some a little bit background, going to use some terms so that we're all on the same page. Then we'll go through traditional integrations, then how integrations have evolved. We will touch base on Ellucian Ethos at the very end, but the bulk of this is going to be how to modernize your integration architecture and why you should modernize your integration architecture. So just as a quick background here, the first thing I wanted to find is when I say digital transformation, what exactly I mean. It's a great buzzword. It gets thrown around a lot. But the definition I'm using is basically changing people, processes, and technologies to enhance the customer experience. And so there's a lot of vendors that focus really on the technology part of digital transformation. You hear a lot of things about moving to the cloud to start your digital transformation journey. But it's really important to remember that there's the people and the processes aspect of digital transformation. And just moving to the cloud doesn't necessarily help things if you haven't re-engineered or refined your business processes or the way your people work. So with the notion of enhancing the customer experience, what we see in digital transformation is more investment in what I call best of breed solutions. The days of having one solution to do everything are long gone. And there's a lot of different vendors out there that offer a great customer experience throughout their product, and they're smaller products and more focused, and they do what they need to in a more efficient and a better experience for the students. So with digital transformation, we start looking at a lot of these best of breed solutions. And while the best of breed solutions are great, they provide a great experience, I think most people in IT have understood that there's often an integration component to introducing a new solution, and actually building integrations to the new solution from the new solution, and uh, the solution won't be successful without these integrations. So this is something I took out of an article. The URL will be at the bottom if you want to look at it. But in a study going all in on digitization or digital transformation, what they've seen is the number of point-to-point integrations rises almost 50%. So it almost doubles just from going through your digital transformation. At the same time, when you're invested in these point-to-point integrations, a lot of reuse of services goes down and out the window. Everybody's moving so fast. A point-to-point integration is a little bit easier to build. And so we just do things quickly to keep moving. And we don't look at the reuse and how this is going to impact your maintenance costs in the future as you're maintaining all of these integrations. And point-to-point integrations, as a lot of us know, they're expensive to maintain. And as you increase the number of solutions on campus, and increase those point-to-point integrations, it sometimes becomes so costly just to manage those point-to-point integrations that it makes it very hard. And while you're providing a good customer experience, you're also the institution's paying a lot more to maintain just these integrations, with the idea that the less you spend on integrations, the more you can spend on other solutions to enhance your student experience. And there's that URL there. So let's level set on the reality of traditional integrations today. We all have a lot of one-off integrations or point-to-point integrations. And when I say point-to-point integrations, what I mean is an integration from one solution to another that works for those two solutions and those two solutions only. So what you're really doing is you're tightly coupling these solutions through the integration. And you don't get much reuse out of it because it was built specifically for those solutions and can't really be reused anywhere. And what happens here is the more systems you have in your integration ecosystem, when you add a new solution, you don't just add one integration, but you can have your integrations grow exponentially. So that one solution you add might have to integrate with 5 or 6 or 10 other systems on campus. And so for one solution, you might be building 10 point-to-point integrations, and that just grows with each system added. And with that, the complexity of your integration ecosystem grows alongside by it. Not meant to really see closely, but this is just an example I got from an EDUCAUSE article showing what a system of point-to-point integrations looks like. If you know your institution's integration architecture, it very well might look like something like this. Lots of errors, lots of different systems connected to each other. And if you add a new system, you might add 2 or 3 or 4 more errors. And that model ends up being very expensive to maintain. Oftentimes, from surveys I've seen, we're talking about investing hundreds of thousands of dollars each year just on maintenance of integrations. So your institution may spend over $100,000 just maintaining the existing integrations, and that doesn't even include building new integrations in that cost. The other limiting factor to the traditional integrations today is there's very few real-time integrations. And that's really where the industry's moving towards. That's where students are moving the industry toward. And we'll talk about these real-time integrations a little bit more. So this is a little bit bigger. It has the URL where I got this out of an article. Hopefully this, for those involved in integrations, this probably looks familiar. I've seen these things much more complicated than what I have on the screen here. And it's just an unwieldy mess. So one quote that I love that kind of ties along with this presentation is, and something to think of as you think of the impacts of your integrations, is making technology fit so you don't even really notice it, so that it's part of everyday life. So can you make integrations work in at your institution so people don't even know they exist? They don't need to know that they have to wait a few hours for their registration to pop up in the LMS after they register in the SIS, for example. So the evolution of integrations and really where are they going? So student expectations are changing. And I think we all know this from reading articles, but students expect to have their information up to date at their fingertips, very often on mobile devices. And what this means is students aren't satisfied with batch integrations anymore. They're not satisfied if you say, yes, you just paid your bill, wait till tomorrow to see it updated. It doesn't make sense to them as to why they have to wait a day for a batch integration to run. It's not a good experience for them. Or it might be a few hours if that integration runs every few hours, but this doesn't make sense to them. And they're starting to ask for more and more in real time, as they will get with other non-higher ed solutions. And so really the goal should be to really minimize the number of times students are told to check for updated information later, in a few hours, tomorrow morning, after the integration runs. Really what they're demanding is if something's updated, they should be able to see that in the right systems immediately. And the problem with point-to-point integrations is they don't support those student expectations. They aren't real-time. They're all pretty much batch and flat file based. And they no longer meet the students' expectations as they might have in the past. And so as a result of this, and to get to keep up with your competitors or get ahead of your competitors, evolving the integration architecture really becomes a necessity if you're embarking on a digital transformation and you want to enhance the customer experience as a result of it. So some of the integration patterns we have today, what I'm introducing here with hub and spoke integrations, this is nothing new. It's not anything from, new this year, even new in the last 5 years. Hub and spoke integrations have been around for a long time. They just haven't traditionally been built. And so when you look on the right-hand side, again, the diagrams are just to get a point across. That very top diagram, that's what 12 different systems integrated through, in this case, 66 interfaces looks like. So each one of those lines is a separate application that has to be maintained, that has to be tested whenever you upgrade a system, and that you have to touch and can't be reused. Versus when you look at the hub and spoke integrations at the bottom, well, you have 12 spokes, each for an IT system, but they're all integrated through a centralized hub. And that hub provides services that get reused amongst multiple integrations. And so when you start moving to this hub and spoke integrations area, you're no longer talking about direct point-to-point integrations anymore. And you're moving all of this data through what we'll call a central hub. And that central hub is a single integration point for all systems. And what that does is it helps insulate the integrated systems from changes. And so if I look at my diagram on the bottom right there, if I change one of my IT systems and say I want to change it out, I no longer have to look at every point-to-point integration that supports that system. It might be one, but it could be 10. I no longer have to look at each one. I just need to figure out how to build something to make my services fit with what that system needs. It definitely, if you're ever thinking about swapping out one system for another, no matter how big or how small, using a centralized hub for integrations greatly speeds it up. It relieves the amount of testing you have to do, the amount of development you have to do. And ultimately, it does take some work to get to the central hub, but the cost savings afterwards are tremendous. And that central hub provides what we call reusable services. So I'll use the example of persons. Pretty much every solution needs some kind of person information, and that's part of an integration. I'd say on campuses, probably at least 80% of the integrations, if not more, involve exchanging persons information. Wouldn't it be great if we provide a single service that everybody could use to get persons information, rather than doing it the old point-to-point way, which is building one solution per system or one solution per integration. Also with hub and spoke integrations, the big things is these become message-based integrations. So we're talking about messages moving back and forth in really a near real-time format. And so you're getting out of shoving things into a flat file and SFTPing somewhere else, or doing these batch integrations that try to track all the changes that happen for, say, a single day, for example, and start moving toward these more transactional message-based integrations. And the more systems you have, the more you end up reusing those existing integrations. So if I add a 13th system to these diagrams that needs persons information, I don't need to write a person service at all. I just reuse the existing service. I might have to do a little bit of work to turn my, to make this 13th system understand what's coming out of my service, but I'm not building a whole brand new service that won't be reused anywhere else. And that's where you start cutting costs as you add these new systems. I'm not saying point-to-points can't be done. I'm saying they're challenging, they're complex, and they're much more costly to maintain. Hub and spoke integrations get us out of those tightly coupled integrations, and we have what are called loosely coupled integrations. Since all my services come from the centralized hub, if I swap out one of the systems, it doesn't impact anybody else. If I was in a point-to-point world and I wanted to swap out one of these big circles here, those red lines would be different integrations that I'd have to rebuild. So it could be 5, 10 different integrations that you have to rebuild. versus only needing to get one system to understand your person's service, for example. And what this does is it reduces complexity and it starts promoting real-time integrations, and those are necessary to meet your students' expectations. They're necessary if we think about the quote, our users shouldn't be seeing the technology behind things. And every time we tell them, check your LMS in a few hours when the data's got in there, or check your account tomorrow after the payment system has talked to the SIS, that's not meeting their expectations, and that's actually showing them the challenges of your technologies. And so as we enhance and meet the student expectations by providing more real-time or near real-time integrations, you're starting to go down that path of hiding the technology from the end users and just providing a good experience for those end users. So before I go into the modern integration technologies, I did just want to mention you can provide Q&A at any point. We're definitely planning on having time for Q&A. It's too challenging for me to go through Q&A at the same time I'm presenting, so I'll wait till the end to answer the questions that might come in, but please don't limit yourselves, and please feel free to use the Q&A feature to ask questions that we'll cover when we're done. So when we talk about navigating away from flat files and batch integrations, what are the modern integration technologies that we're talking about using today? And this is not meant to be an exhaustive list, but these are some common things you'll start hearing about. The first is you hear about REST. And REST stands for Representation State Transfer. You don't need to know that. You just need to understand the concept of what REST is. It's an architectural style for developing APIs, and it's very popular because it's very simple. And the reason it's simple is because it uses basic HTTP protocols. Everybody deals with HTTP when you're browsing to a website, for example, or submitting a form on the web. Those are different HTTP actions that happen, such as an HTTP GET, or when you're submitting a form, you're doing a POST. And these APIs are built based on those HTTP verbs, which are easy to understand. They're straightforward. They're established technologies. And we're not imposing any new frameworks, any new technologies on you. It's just a way of adapting APIs to this HTTP protocol. And a big advantage of this is if you understand HTTP, it's very easy to understand REST and how these REST APIs work. Everything is done with HTTP verbs, HTTP headers, and an HTTP body, for example. The other nice thing is encryption. Encryption, which is usually a very complicated thing, especially when you're talking about SOAP services and WSDLs. With REST, all it is it's using TLS 1.2 or TLS 1.3, which are what every website does. And so we're not dealing with like a very complicated way of securing these APIs. We use the encryption that HTTP supports, and we solve transport level security that way. The other thing with REST semantics is it's language independent. No matter which program language you pick up, whether it's Grails or Java, .NET, Python, Node.js, they all have libraries to support HTTP protocols. You're not building anything from scratch to interact with these RESTful APIs. Almost every single language has libraries to assist with development against HTTP protocols. Then moving on, we have what we call JavaScript object notation, and what you've probably heard that referred to as JSON. And so what is JSON? It's a data exchange format that's very lightweight, much more lightweight than SOAP XML, and it's also language independent. It is based on the JavaScript language, but you do not need to understand JavaScript to understand JSON. So you don't have to be a JavaScript programmer to understand and be able to read JSON. In fact, it's relatively easy to understand, it's easy to manipulate and build. And there's a lot of references for both REST, for JSON, all on Google. There's a ton of resources out there to help you get up to speed. So why would we use JSON? So think of REST as the way we're transmitting data back and forth, and JSON being the language or the payload that we're passing back and forth. So like I said, the syntax is very straightforward. It's easy to build and manipulate. Almost every modern programming language understands it, including all the ones that I mentioned earlier. And basically, all of those languages have libraries to support what I call serializing and deserializing of JSON into programming semantics. And what I mean by that is JSON's basically a